Hello everyone, welcome to Explorer Hub. Apply the integral test to see whether the sequence an equals to n divided by n squared plus 1 is converging or diverging. We can use the integral test, which is basically taking the limit. So the integral test says that if you're given a sequence, we can take the limit of the function of the sequence from 1 to infinity, and if that limit is converging or diverging, then our sequence is also converging or diverging. So we can write this sequence as the function f of x equals to x over x squared plus 1. Then we can take the limit as x goes to infinity from 1 to x of f of x, which is equals to limit as x goes to infinity from 1 to x over x squared plus 1. Now that we have this, we can start solving the integral. We can solve this by taking u as x squared plus 1 and du as 2x dx. Therefore, half du equals to x dx. Now we can plug in these values right into this equation, which would basically give us 1 over 2 integral of 1 over u du, and we can take the integral to get half. The integral of 1 over u is ln u, so half ln u. And what is u equals to? We can see that u is equals to x squared plus 1, so half ln x squared plus 1. Now that we have that, we know that the limit as x goes to infinity for half ln x squared plus 1 from 1 to x. We can solve this out. We can plug in the value of infinity, and we get half ln infinity is half ln 0, which is basically equals to, this is equals to infinity. So that means this is diverging. Since our integral is diverging, that means our sequence an equals to n over n squared plus 1 will also diverge. Thank you for joining us. I hope to see you in the next lesson.